In this video, I'm going to go over the problems that I've been asked about the most in the first week of class. So from section 1.1, problem number 20 is the most missed and the most asked about. For the function f of x equals 4x squared plus x, evaluate and simplify. So we want to find what's called the difference quotient. So the first thing we do is we find f of x plus h. That means substitute x plus h in the expression wherever there's an x, and then simplify. So we're substituting x squared x for x plus h squared and x plus h. Multiply, I get 4 times x squared plus 2xh plus h squared, because that means x plus h times x plus h plus x plus h. Distribute the 4, we get 4x squared plus 8xh plus 4h squared plus x plus h. So there are no like terms, so this is the expression, the f of x plus h. Now we're going to subtract f of x. So now we're going to take that expression minus what f of x is, which is 4x squared plus x. Then we're going to divide the whole thing by h. So from here, when you distribute the negative through, you'll end up with a minus 4x squared and a minus x. This 4x squared will cancel with that one, and there should be an x that cancels with an x, and what you're left with in the numerator, every term has an h in it. So we have 8xh plus 4h squared plus h all over h. Now the last step is to simplify this expression. We can factor an h out of the numerator and cancel with the h on the bottom. If we factor out an h, we're left with 8x plus 4h plus 1 divided by h. So the final solution is 8x plus 4h plus 1. All right, next problem I've had the most questions about are the piecewise functions in section 1.2. This one is problem number 15, and I think mostly it's a matter of how you're graphing it on the graph, so I want to give you a hint on that. So we're going to graph these three equations on the same graph, but only for limited values of the domain. So the first graph we're going to graph is the line x plus 4, but we only want it for values x less than or equal to negative 3. So we have to figure out where we start. When x is negative 3, we get the coordinate negative 3 plus 4, which is 1. So this graph starts at negative 3, 1. Then the slope is 1. So it's a positive slope, or you could actually just find another point. Pick another value less than negative 3, which is negative 4. If I substitute that in, negative 4 plus 4 is 0. So negative 4 is 0. So right now I know that that's x is less than or equal to. There's that piece of the graph. The next is to graph negative 2 between negative 3 and 2. So negative 2 between negative 3 and 2. Now you see where there's a break in the graph? This is where you need the open and closed circles. So now that's open, they're not overlapping, so I need to put a closed dot there. You're going to use this dot key to put that. So now I'm going to graph the horizontal line between negative 3. It doesn't include negative 3, so I'm going to put an open circle there. So you'll need an open circle because it's a break, and 2. Now I'm not going to put an open or closed circle yet because I need to see what happens on the next graph. So now I'm going to graph, I'll write it as a fraction, 3/2 x minus 5 for x values greater than 2. So when we put a 2 in there, I get 3/2 times 2 minus 5. 3 minus 5 is negative 2, so I get the coordinate 2, negative 2. It's going to overlap with this other graph. Oops, I put it at negative 3. Let me erase that real quick. There we go. That should be up here at -2. So let me put the open circle there and then closed at 2. Okay, I didn't put anything yet there. So this graph overlaps at 2, -2. So we don't put an open or a closed circle. Okay, the slope is 3/2. So from up here, I'm going to count up 3 to the right 2. So there's our piecewise function. You'll just use the drawing tool to draw this part with the closed circle. Then you'll have an open circle drawing tool. You won't have open or closed here because they overlap. And there's your function. All right, next one is problem 16. This one is identifying each of these parts of the graph from the picture. You're given the domain and you have to fill these in. So each of these are straight lines. So you'll have to remember equation of a line. So I can get the middle one pretty quick. It's a horizontal line that hits 3. So that's the equation, y is equal to -3, or f of x equals -3. The other two graphs, we want to figure out their y-intercept or their slope, or you can find the equation of a line between 2 points. But every line has mx plus b. So for the first equation, I can find the slope. And we're traveling from this point to this point. The slope, let's see, I'm going to pick a point on the graph. Down 1, 2, 3, to the right 2. So the slope of that is -3/2. Then to figure out the y-intercept, pick a point. I'll pick this point -3, -2. Substitute it in here. Y is equal to -2 equals -3/2 times x plus b. Solve. -2 equals 9/2 plus b. Add 9/2 to both sides. Oops, subtract 9/2 from both sides. So -2, it would be -4/2 minus 9/2 would be -13/2. So the equation of this line is -3/2 x minus 13/2. And then you'll do the similar to find the equation of this line. Find the slope and then put in your x and y values in the slope to find where the y-intercept is. All right, last question that was most popularly asked was from section 1.3, problem number 1. You were given a table for f of x and g of x, and you were asked to find the average rate of change of the function g from x equals 0 to x equals 1. So ignore this part of the table. So what you need in the function g is you're given the x coordinates of 0 and 1, and you want to find the y coordinates or the g of x coordinates that go with them. So at 0, g of x is 8. At 1, g of x is 5. So we want to find the average rate of change from the point 0.8 to the point 1.5. So we put it in the average rate of change, which would be g of 1 minus g of 0 over 1 minus 0. G of 1 is 5. We get 5 minus 8 over 1 minus 0, which equals -3 over 1, which is -3. So I hope that helps. Those are the most popularly asked questions on homework last week. So hopefully that will help you prepare for the quiz, or if you want to go back and revise homework, you can.